Hello all, this is Sai Samyarani Singanamala. I am the student of EEE 236 at Sac State. Today I am going to discuss about the importance of machine learning and artificial intelligence in semiconductor manufacturing industry. The outline of this presentation is first we are going to discuss about the introduction, what is meant by machine learning and artificial intelligence and how they are impacting semiconductor manufacturing industry. And then I'm going to explain about the IC metrology and challenges in semiconductor manufacturing and what is meant by virtual metrology system and where machine learning and artificial intelligence comes into picture. And then we are going to discuss about the structure of virtual metrology system and internal details as well. And then we are going to discuss about the advantages of virtual metrology system and machine learning AI impact on growth in semiconductor industry. And then we'll conclude with the brief conclusions about the machine learning and artificial intelligence. Since the creation of the first IC device in 1960, the semiconductor industry started growing rapidly. Basically, the density of the devices manufactured on silicon substrates has been marvelously increased in recent years. Actually, the semiconductor industry strides forward into the ULSA era. Not only the device geometry continues to shrink, but also the fabrication process become more complex. Basically, nowadays the typical IC fabrication involves more than 350 process steps. Each process step has specific quality standards. So IC metrology is the process which is used to check the fabrication performance. It plays two important roles in the process flow. In IC metrology processes, there is an intelligence system involved based on machine learning and also artificial intelligence. Machine learning and artificial intelligence are playing important role in semiconductor industry nowadays. In order to build a knowledge-based system that automates some of the tasks in manufacturing process, detailed domain expert knowledge has to be gathered. This step is very important for any kind of knowledge-based system as it needs the expert knowledge and required for that system implementation. This step is also the most time consuming and there will be always the danger of invalid or incomplete knowledge transfer between the domain expert who is dealing with that particular area and the developers of that system. In this point, the machine learning techniques may decrease the development time of such systems and they often reveal knowledge that might be overlooked by those acquiring the domain knowledge. So machine learning is very important at this point. So basically machine learning provides methods that can generate solutions for complex problems. By giving the history of the previous outcomes, we can make it intelligent. This is nothing but machine learning. For some problems, it is not feasible to specify the exact solutions manually. So, machine learning techniques can be seen as very useful tools for pattern discovery in large datasets. As we discussed in the previous slides, IC metrology is the system which is used to check the performance of the fabrication process. It plays two important roles in the process flow. First one is semiconductor industry continually faces quality control challenges. Metrology tools provide cutting-edge solutions to measure critical process parameters such as thickness, composition and roughness of the thin films. These tools inspect whether the wafer result has defect or not, which is strongly related to the yield. The second one is most of the semiconductor processes have nonlinear dynamics due to the physical and or chemical reactions. Many of them suffer from the drift and the disturbance. So by changing the process, it affects the outcome of that result. Now we are going to discuss about the challenges in semiconductor manufacturing. In semiconductor manufacturing, one of the challenges is the thickness prediction of chemical vapor deposition on wafers. Using virtual metrology system and root cause analysis, one can detect irregularities in CVD material thickness, thus predicting the wafers of lower quality. In the semiconductor manufacturing, process recipe specifies a set of operation conditions. Changing the set points of the recipe may impact process outcome. Then while sometimes there can be no difference in the recipe is only fine-tuned. Moreover, some process parameters may be conflict with each other. So sometimes the process recipe has complicated correlation with the fabrication result and also the yield. Besides this, there are many processes exhibit inevitable steady drifts in nature because of the gradual wearing out phenomena or maybe buildup of material on the components of the tools. It results in variations in the fabrication outcomes from wafer to wafer. Due to this process drift, the recipe has to be modified between the runs in the process. So basically the process outcome signals contain the information of system dynamics and process drift and also disturbance. So under this kind of circumstances, predicting the wafer outcome becomes more and more complex. Therefore, to predict the wafer result precisely and correctly, we have to use virtual metrology system. This is capable of capturing the system dynamics and take the change of recipe into account. So at this point, in this virtual metrology system, machine learning and artificial intelligence techniques come into picture. So if you observe in this diagram, we can see that there are three main blocks. One is process tool, one another is metrology tool, and the third one is virtual metrology system. If you observe virtual metrology system, there are two inputs. One is recipe and one another is historical metrology data. So here machine learning techniques are come to picture because it is taking historical metrology data as input. We are feeding the history of the data into the virtual metrology system. So outcome of this virtual metrology system is prediction of wafer outcome. So it can predict the wafer outcome so that we can mitigate the problem. So it estimates the process results based on the previous metrology measurements instead of measuring practically. Recipe changes results the process shift and also linear drift. Process drift estimates using machine learning techniques such as PLNN, that is nothing but piecewise linear neural network, and also fuzzy neural network. So in this slide we are going to discuss about the structure of the virtual metrology system. So here we can observe two different blocks. One is piecewise linear neural networks and one another is fuzzy neural network. So if we discuss about the piecewise linear neural network, Although most semiconductor processes have approximately linear process drift, the curve of time series usually shows rut because the signal is disturbed by noise and recipe adjustment. So therefore, the information of the trend of process drift must be extracted from the time series first so that that influence of process recipe can be considered as independently. Hence, piecewise linear neural network is employed for estimating the drift. The basic idea is quite straightforward here. Like time series is partitioned into several clusters. So each cluster is approximated by linear function that indicates the trend of process drift. The jump between successive clusters shows the shift of wafer outcome due to the change of process recipe. So it is assumed that the process is under the normal operating system or operating condition. The shift of wafer outcome is not the result of machine faults. So, and one more process is here, that is fuzzy neural network. Fuzzy neural network is to establish the process model. So by getting together these blocks, we can build a virtual metrology system. So machine learning takes place here to develop these two blocks. In this slide, we can observe this image which illustrates the virtual metrology concept in addition to physical metrology. So if you observe at the top of this image, the actual metrology approach in semiconductor manufacturing process is displayed, with sample wafers measured at the metrology equipment and also the corresponding control chart with upper and lower limits. If you observe in the bottom of this image, predictive machine learning models with input from sensors of the process equipment and also metrological data for training purposes are shown. So it is getting both the inputs as like process sensor data and also metrological data. So it uses those two and it will predict the outcome of this process. So the resulting chart contains predictions for unmeasured wafers as well. So let's discuss about the advantages of virtual metrology system. So it reduces the wafer scraps. Basically, process inspection can be performed through virtual metrology for every wafer to sustain yield performance and tighter process control. So virtual metrology provides a basic to overcome the metrology delay problem for run-to-run control. Increasing the throughput. So here we are increasing the throughput using virtual metrology system, like wafer handling from process tool to metrology tool can be reduced and thus production cycle time can be shortened. So we can reduce the time. Now let's discuss about the companies will find many opportunities in the artificial intelligence market with leaders already mentioned. So there are different categories. For example, let's take compute. So in compute, there are a lot of opportunities in existing markets such as accelerators for parallel processing and GPUs and also FPGAs. So we can say potential new opportunities like workload specific artificial intelligence accelerators. And if we take memory, we can design high bandwidth memory and also on-chip memory such as static random access memory and emerging non-volatile memory as well. Coming to the storage, we can potentially grow in demand for existing storage systems as more data is retained. And artificial intelligence optimized storage systems and also emerging non-volatile memory. Coming to the networking part, so infrastructure for data centers and also programmable switches, high speed interconnect. Because of the artificial intelligence and machine learning techniques, companies are growing day by day. For example, AI related semiconductors will see growth of about 18% annually over the next few years, 5 times greater than the rate for semiconductors used in non artificial intelligence applications. It's 5 times more compared to non AI to AI. So by 2025, we can say that artificial intelligence related semiconductors could account for almost 20% of all demand, which would translate into about $67 billion in revenue. And opportunities will emerge at both data centers and the edge. If this growth materializes as expected, semiconductor companies will be positioned to capture more value from the artificial intelligence technology stack than they have obtained with previous innovations, about 40 to 50% of the total. This much growth we can observe in coming few years because of AI and machine learning technologies. Yeah, if we observe in this graph, we can observe the growth for semiconductors related to artificial intelligence is expected to be 5 times more than the remainder market. So if we observe in 2017, there are 240 total companies out there. Among those, 17 companies were working on artificial intelligence. So we can see in 2020 the number is going to up in artificial intelligence based. So it enormously increasing day by day because of that technology performance increasing, and we are giving less time for the production so that we can expect within the very short amount of time the productivity is enormous. So there are a lot of applications based on machine learning and artificial intelligence nowadays. There are like many areas which are developed by the artificial intelligence and machine learning. For example, in medical and also in semiconductor industry, and there are a lot of industries which are developed by machine learning and artificial intelligence technologies. So we can conclude that machine learning and artificial intelligence are very important for semiconductor industry. So we have discussed one really good example for that, which is virtual metrology system, where we can develop our system based on machine learning and artificial intelligence technologies. And many applications are working on artificial intelligence and machine learning nowadays. Because of this intelligence, performance is increasing day by day enormously in every industry. Time, performance, intelligence are crucial things nowadays. Because of these emerging technologies, there is a scope for a lot of innovations in semiconductor industry. Thank you.